Emertex Information Technology. Our internship is based on embedded systems, and our project name is Washing Machine Simulator using PIC 16F8778 microcontroller. I am V. Sai Prasanna. I am currently pursuing BTech third year from Acharya Nagarjuna University of Engineering, Guntur. Myself, Duppala Bhuvaneshwari. I'm currently pursuing third year BTech in Dr. Y.S.R. Acharya Nagarjuna University College of Engineering, Guntur. So our project name is mainly washing machine simulator using the microcontroller, that is PIC 16F8778 microcontroller. So the table of contents, it contains main contents of the project. Introduction, embedded systems and design and its components, software used, PIC microcontroller, embedded C, peripheral description, project demonstration, and sample outputs. These are the list of table of contents in our project. So the first introduction of this project is mainly now we are commonly using washing machines. So the washing machines are used to reduce human labor and save time. So washing machines have an important place in the modern society. Nowadays, we can see various kinds of washing machines. Customers want to have fully automatic machines instead of semi-automatics. In this project, we will build a simple washing machine prototype using a microcontroller, that is PIC 16F8778 microcontroller. So this was the main introduction of this PPT. And now, embedded systems. We should all know what is meant by embedded systems. So, it is a combination of both hardware and software electronic gadget to do a specific task. So, the embedded systems have a common examples of it includes the microcontrollers in household appliances like washing machine, industrial control systems in manufacturing plants, navigation systems in automobile and medical devices like pacemakers and insulin pumps. So these are the basic examples of embedded systems used in our day-to-day lives. And the next topic is about the block diagram of embedded system. So the embedded system block diagram contains of two parts. So the first part is about the based on performance and functional requirements, and the second part is about the based on the performance of microcontroller. So these two parts combine to form an embedded system. And coming to the first part, based on performance and functional requirements, they are subdivided into four parts that are real time, standalone, networked requirement, and mobiles requirement. These are the four types based on performances and functional requirements. And from the second part, based on the performance of microcontroller, we are using a small scale, medium scale, and sophisticated. So these are the types based on the performance of microcontroller. This was the entire block diagram of an embedded system. So the components used in embedded systems, like there are many components used in the embedded system. Embedded systems are software, memory, data to analog conversion, diagnostic part, memory of port, and analog to digital conversion, FPGA, field programmable gate array, and ASIC, which stands for application specific integration circuit. So, next in user interface and software. So, these are the components used in embedded systems. This topic is about PIC microcontroller. So we are in this that the PIC microcontroller has a model of 1678778 microcontroller. So to build this project, we are using this microcontroller. So every microcontroller has a specific specifications, has a different specifications. In this type model microcontroller, we have a specifications. Then this PIC microcontroller, it has a 40 pins and has 5 ports in total. Port A, port B, port C, port D, and lastly port E. And this the port A contains 6 pins and port B contains 3 pins. Port C contains 8 pins. Port D contains 8 pins. And lastly port E contains 3 pins. In this, the PIC microcontroller supports the serial communication and it has 2 pins. In this serial communication has 2 pins, TX and RX. TX is the transistor side and the receiver side. And PIC microcontroller, it can also support SPI protocol. We have oscillator frequency range from 4 megahertz to 40 megahertz. So the PIC microcontroller has a oscillator frequency range from 4 megahertz to 40 megahertz. And mainly the softwares used in our project are picsim lab software and next MP lab XIDE software and XE9 compiler and pic genius and pic 16778 microcontroller board. So these are the main softwares used in our project of washing machine simulator. Now we are using the code part. In this, the code part has a software part has C language. So we are using embedded C language in this project. So C is important for embedded systems due to its efficiency, portability, and low level access. And it easily enable the precise control over hardware and optimal resource utilization. So these are the main advantages of using C language in embedded systems. Data types and variables in embedded C. So understanding different data types and languages, variables, declarations for efficiently memory usage. In this, we have different data types like pointer and memory management, control structure, programming, functions and modular programming, and preprocessor directive. And firstly, the pointer and memory management, which means manipulating the memory address and accessing hardware registers directly. And secondly, control structure, which means implementing the decision making and the repetitive tasks. Coming on third, functions and modular programming. So in this, the modular programming contains a encapsulating reusable code blocks and facilitating modular software design. Preprocessor directive, manipulating source code before completion for defining constants and conditional completions. So these are the main different data types and variable declarations in embedded C. And next, coming on to peripherals. This is one of the components used in the washing machine simulator. In this, peripherals comes under LED. LED, which means light emitting diode, is a semiconductor device that emits light when an electrical current passes through it. LED commonly used in many applications. We all know LED is an external device connected to microcontroller port. In this, it contains a LED structure having an anode cathode side. In this, anode side has the longest lead and cathode side has the shortest lead and the flat side. These are the main components in LED. And port interference between the controller and external peripheral. In this, the LEDs are commonly used in various applications, including indicators, displays, and as components in electrical systems due to their efficiency. So, they are mainly used in electrical systems because having an higher efficiency. Tactile switch as digital keypad. In this, there's the tactile switch, which are used in microcontrollers. Switches are often used as inputs to control the operations of the device or to interact with the user. And next, tactile switch is pressed, the switches turns on, and when the button is relaxed, the switch is turned off. So if the button is pressed, the switches turn on, and the button is relaxed, the switcher is turned off. So they are typically connected to specific input pins of the microcontroller, enabling the direction of switch state changes. So these are mainly about the tactile switch, which are used as a switching inputs as a digital keypad. And next, CLCD, one of the main component, which means character liquid crystal display. The LCD liquid crystal display is a flat panel display technology that uses liquid crystals as modules light and display images or text. In this, the LCDs liquid crystal display operate by modulating light through light crystals. So they will modulate through light by light crystals controlled by electronic signals or electrical signals. So in this, the importing pins for interfacing with an LED, it includes the power like VDD, VSS, and controls like RS, RW, and C, and data lines having from 0 to 7 data lines, along with the contrast control pin VO and black light pin A and K. So this is about the one of the components ELCD character liquid display crystal display component. Interrupts. Interrupts are majorly having of two types, software and hardware interrupts. Interrupts in microcontroller are the software or hardware signals that temporarily suspended the normal program execution to handle the crystal events and the external stimuli. So the internal or external requires to the microprocessor unit MPU to stop the processing. So interrupts attends to the request. And as we all know, we have two types of interrupts, hardware interrupt and software interrupt. Timers. So the timers is microcontrollers are versatile hardware modules used for measuring time intervals. So the timers definition is microcontrollers are versatile modules used for measuring time intervals, generating precise timing signals, and implementing time crystal operation. So they can be configured to various modes, including timer counter, pulse width modulation, PWM, and capture or control modes catering to wide range of timing requirements. In this, the timers often has a featured adjustable prescalers and reload values, allowing for a fine-grained control over the timing resolution and periods. So the major applications used in timers such as motor control, communication processor, and real-time systems. So these are the major essential applications used in timers.
So now I will go through the code section. So MP Lab XID, it is a platform where we write the code. In this code we have two main folders. That is, one is source file and header file. Source file includes the main.c. So now we will show the program. That is, we have mainly three header files that it include cld.h, include digital keypad.h, and include timer.h. So these are the three header files used. After this, we are going to initialize the values for the header files. That is, we will initialize the values for fan and buzzer as 0. Here 0 indicates off and one indicates on. So let us see how to build and clean the program. To build and clean the program, go to the folder, right click on the folder. Here you see the option like clean and build. Click on the clean and build. The program will clean and build. So if the program does not contain any error, it will load like the clean and build is successful. So if the clean and build is successful, the program is meet with zero errors. This is the code part.
This is the platform picsim lab board. Now here we will go to board and we will select this picgnios option. Click on this so that it will start. Then we will go to microcontroller. Click on PIC16F87A option. Click on this and also we select the clock size as 20 and LCD as HD 44780. 16 into 4. This 16 into 4 means that 16 words into 4 lines. Each line is divided into 16 characters or letters. So this is the option used here. If we want to extract the .hx file, we have to go for file. Here load hx. Then you have to click on where the file is present. My file is in the desktop washing machine simulator. Then click on the washing machine simulator. Then click on disk. After that click on default. Then click on production. Then you can see the washing machine file. Click on this. Click on open. The file will be opened. So this is the starting point of the project. Here the first step, we start with the keys. There are three keys namely used. So RB3, RB4 and RB5. RB4 indicates key 5 and RB3 indicates key 4 and RB5 indicates key 6. So these are the keys used in this program. To start the program, I will be pressing RB4. So press key 5, RB4 to start the program. Now the washing machine is power on and the awning of the washing machine is done. Now if you want to go to the next option, click on RB3 button so that you can go to the next option. This button helps you to go to the next option. And one more thing is you have to press a short press so that it will go to the next option. If we click on the long press on RB3 button for 5 to 7 seconds, it will choose a particular option and it will work on it. So let us try. I will be clicking the RB3 button for 5 to 7 minutes. So let's see. So I have clicked RB3 button for long press for 5 to 7 seconds. So it's showing me to select the water level. So there is 3 levels of water, that is auto, low, medium. So I will select as low and I will click on RB3 long press to select the water level as low. So I will be clicking for low for 5 to 7 seconds. So I will be clicking on the low. So I will be clicking on this RB3 button for 5 to 7 seconds. So after pressing on RB3 button, so it will ask for start or reset. The start button is RB4 key 5 button and for reset RB5 key 6 button. So to start the program, I will be pressing RB4. So it will start the program. I'll set on RB4. So now the washing machine starts running. Here if there is any interrupt in between, so this RB0 is an interrupt key. So if you press on RB0 for long time, there is a buzzer sound. This buzzer sound the program. So the time 1 minute 6 seconds. Now after it completes, there will be another buzzer sound here, which indicates the completion of the program. So the main keys used here is RB3, RB4 and RB5. RB3 indicates the key 4, RB4 indicates key 5 and RB5 indicates key 6. So RB0 indicates the interrupt key. So the remaining time is 50 seconds. After 50 seconds, the washing machine completion is done. Here we have port A, port B, port C, port D. These are the ports which we have seen in previous PPT slides. So these are the ports used in picsim lab board. Then remaining 30 seconds, the completion of the program will be done. So these are the heaters, buzzer coolers, these are the options and other options available in the port. So we will see how the completion of washing machine is going to be done. So remaining is 12 seconds. We will wait for the completion of the washing machine. Now the PR is completed, washing machine is also completed. It will go to the next level, means if you want to reset, you can also use the option in picsim lab, and these are the available keys used in this. So working of washing machine.
Conclusion. The washing machine simulation using picsim lab served as an effective tool for learning and applying concepts in embedded systems. It offered hands-on experience that complemented theoretical knowledge and provided a foundation for further exploration in the field of automation and control systems. Thank you so much for the whole Emertex team for your time and guidance throughout my internship. Your support was invaluable. We are grateful for the opportunity to have worked with you and for all the knowledge you shared. Thank you for being such a great mentor and for your constant encouragement. Thank you.